This is part 3. We're going to go ahead and look at our moles and then compare and figure out our mole ratio. Now, our percentages were a gram ratio, which would be true no matter what the sample size is. But because chemical formulas deal with single atoms, single molecules, counting atoms, we want to have a ratio that is whole numbers, not percentages, not fractions. So if we go ahead and take our part that is water and divide by water's molar mass, then we should be able to get moles of that. And if we take our part that is salt and divide by its molar mass, we should be able to get that. So you can see I'm taking my 2.41 grams of water. I'm going to divide by the molar mass of water. I'm showing it here in dimensional analysis so that we can see that grams cancels and that moles will be left. And a mole of water is about 18 grams. How do we get a molar mass? If you've forgotten, we're going to take the molar mass of each atom type times the number of times we see that atom type and add them together. So we basically get 2 times 1 and roughly 16 added together to give us our 18. When we cancel out our units, we'll notice that moles of water is all that's left. To do our dimensional analysis, we'll multiply across the top and divide by the bottom and get 0.13378 moles of water. We're going to go ahead and do the same thing for salt. Remember, your salt is going to be magnesium sulfate for this, but depending on which of the 6 you got, the molar mass will be different. The concept is still the same. Take the mass of the anhydrous salt and divide by that salt's molar mass. In the case of magnesium sulfate, it's 120.3676. Again, how did we get this? We have roughly 24.3 grams coming from the magnesium, another 32 from the sulfur, and then 4 times 16 from the oxygens. When we cancel out our units, we'll see that we get moles of magnesium sulfate, and then we'll go ahead and multiply across the top and divide by the bottom, and that will give us 0.017197 moles of magnesium sulfate. Now, we have moles. Moles does provide us with a ratio, but it's not a nice simple ratio. So first in number 11 and 12, we'll insert our mole amounts that we just determined. After that, we're going to go ahead and determine the 1 to x ratio. The way we'll do this is by dividing both of our mole amounts by the smallest mole amount. This will simplify our ratio so that it is in whole numbers, or at least numbers that we can deal with, where it's 1 to something else. No matter what salt you get, I'm going to force you to divide both mole amounts by your salt mole amounts. When you do that, you'll always get one formula unit of salt, but you'll get a differing number of water molecules. So let's go ahead and figure out what that ratio is. Again, we want salt to water for our ratio. So if we take the salt moles and divide the salt moles by them, we will get 1. When we take the salt moles and see how many times they go into the water moles, that will give us a different number. And because the water moles is typically going to be larger than that of the salt, we'll get a number that is bigger than 1. So if we take 0.13378 moles of water and divide by 0.017197 moles, leave the salt off, moles will cancel, and it will tell you that we have 7.779 water molecules for every 1 formula unit of magnesium sulfate. You may be tempted to round. Please do not. In question number 13, please enter in the value that you got, even if it ends up with a whole number and then a decimal portion, like I have, with 7.779. On to the bonus. Percent error allows us to determine how far off from the expected value we were. You'll take the absolute value of the calculated value, your lab value, minus the accepted value. You'll then divide by the accepted value and multiply by 100%. You can see that here in the form, but I'll go ahead and write it down anyway. Again, absolute value of my calculated lab value minus the accepted value divided by the accepted value times 100%. Now again, the 7.779 was my number 13, and it is my lab value. The whole number 7 is the accepted value. When I do this, I get 11.13% error. In order to get the bonus, you'll go ahead and you'll insert that in question number 14. If your teacher has not set it up as bonus, just do it as part of your lab. Don't forget the final questions and whether your value was too high or too low. You'll notice that you can select with an X too high or too low, and it will turn green or red. I got 7.779. That was too high. I expected 7. Make sure you read through all of the sources of error. Remember, during the heating process, some of the salt may have escaped. It may have been projected out. The crucible might have had water on it, which would need to boil off, causing additional weight to be lost. Some of the crucibles really aren't that clean, and so some of the gunk that's on the inside may have caused it to react. Maybe you didn't heat it long enough, and some of the water's still trapped on the inside. Maybe a side reaction took place, and so you may have smelled an odor, or maybe you can visibly see something has happened to the material. And I don't think anyone is going to get this perfect. There's always going to be a little bit of rounding up or rounding down that's going to cause an issue.